Hi, I'm Carrie. I'm an SRE at Noble9, and this is Zero to SLO Hero. So we're going to go through all the tools to get you started with SLOs from complete scratch. So hopefully, if you don't already have prior experience with service level objectives, by the end of this video, you'll have a good grasp of the concept. So we're going to start with the basics. We're going to go through some of the definitions and the math behind the calculations of service level objectives. And then in a separate video, which will be part 2, we're going to go through some actual examples with queries and the pros and cons and challenges you'll likely face trying to set this up at your own company. So let's dive into it. We're going to start with a little bit of history. So service level objectives originated with the Google SRE team. And it was first really well documented in the early 2000s in this little paper called Site Reliability Engineering: How Google Runs Production Systems. And the reason they needed something like this was because service level agreements, or SLAs, which had already existed for a long time, were incredibly limiting and just not flexible. So, because of the legal ties involved with SLAs, they're not as easy to change on a whim, and Google was scaling like crazy. So they needed something that was going to allow them to be more realistic as they scaled. So they created this new variation of the SLA method, and it was helping engineers maintaining the systems focus on the customers that were using the product. And what this did was allow for a lot more nuance in their approach and ultimately help them be a lot more realistic about how they set their SLAs. They also found this method was helping with their decision-making process because it's hard to stay agile at scale. There's so many cooks in the kitchen at that point. But SLOs were giving them a lot better data to make better informed decisions. So what can we take away from that? Why service level objectives, right? I think a good SLO factors in the human experience to the way that we maintain our services. And that's going to help us make better and faster data-informed decisions. So to me, my favorite part about SLOs isn't just that we're measuring our services in a way that makes more sense, but it's actually that it helps our engineering team see the whole picture of what you're working on. Sometimes we all get into our own little individual pieces of what we're working on that we lose sight of the big picture and how our work is actually affecting our customers. And we can end up putting ourselves through grueling hours of on-call just to meet some arbitrary standard that somebody set. But SLOs really force us to think about the end user and how they're interacting with the services we build. So ultimately, we can be way more realistic about the goals we set for ourselves when we shift our perspective that way. Most systems still need humans. And while that's a bit of a rabbit hole of a conversation, we're going to keep that topic high level. But most systems have humans as users or maintainers, right? And historically, we just haven't done a good job of factoring that into our reliability standards. So SLOs are really meant to bring this full circle, keep the human factor front and center so we can make sure we're taking care of all the humans involved. I think business is often described as customer first type of mentality, and that I think negates that there are humans also behind the services that the customers are using, and we want to make sure that they're being taken care of just as much as the customers. So eventually that could all change, machine learning, AI could change the whole way we think about reliability. But I think we still have a long way to go in terms of fixing the culture around that. And that's going to always be there regardless of if machine learning can help us or not. So let's get started with some basic definitions that often get conflated. So there's SLIs, SLAs, SLOs, and EB. And I know that's a lot of acronyms, so we're going to go through them one by one. So let's start with SLIs. Service level indicators, or SLIs, are a quantitative measure of some piece of how we define our reliability. So we'll go through some examples of SLIs in the second video to get you started. But for now, we're going to want to remember that an SLI is a query from a system that we use to monitor our service that will help us measure a specific aspect of our reliability. So it might tell us something like how long it takes to process X to return a response, which would be something like a request latency, or it could give us a fraction of where we get the number of errors over the total amount of requests received so that we can see some percentage of how often things are erroring out and not working. And we're going to use this data from these SLIs to tell us how well we're meeting our objectives. So here you can see a pretty standard Datadog dashboard with some Kubernetes nodes metrics. This is the type of thing that you're going to use in your SLI, where you can pull information from like memory utilization or CPU utilization to factor in how you're meeting a particular reliability standard that you set. So I just wanted to show you this as a quick example, but moving right along here, there are two main types of SLI queries that you might come across. The first one is the threshold, which is just the request has to be within a certain range to be considered met. And then the second one is a ratio, which is a relation between two metrics. So it's usually something like a measurement of good or over total. A lot of people struggle when they're first starting with what to measure. It's hard to kind of correlate what is happening with your customer to what's happening in your system. And so Google came out with these 4 golden signals: latency, traffic, errors, and saturation. And this is a good place to start, but these aren't the only ones that exist. So latency is the time it takes for a system to respond to a request or complete a task. That could be like how long it takes for a particular page to load. There's traffic, volume of requests or transactions a system's handling. How busy is this page? How many people are on it? Errors, the rate of errors or failures that are occurring in a system. That could be like how often this page is giving you a 404. And saturation, which is the degree of the system's resource utilization. So that could be like this system is running at 95% CPU consumption, right? That's going to severely limit what that system can process at that point if it's really high. So again, like these aren't the only ones that exist. There's a lot of other common SLIs like availability, how often a service is responsive, throughput, the number of requests or transactions that can be handled at one time, queue depth, number of requests waiting to be processed by a service. If you are realizing that you have a limit of how much your system can handle at once, you might start getting a queue. And depending on what's happening in your system, that queue can get so big that it's not going to be processable anymore. So that's something that you want to keep in mind potentially in an SLO. And my favorite one, correctness, which is how often does a service return the correct or expected response? So, if you have a little calculator app and you're processing 2 + 2, but you're always returning 5, it's not going to be very useful because it's not a correct response, right? So we also want to make sure that we're factoring in correctness. So these are just some common examples of things that you can measure with SLIs. Again, there's lots of other ones out there. It really depends on your system and the needs of your customer, but I like to think of these as like just a way to quickly get you started for a lot of common services that are out there. And again, in the second video, we'll go through some actual examples with some Prometheus queries as well. So next up, we have SLAs, or service level agreements. And these are the ones that most people tend to be familiar with. And these are really reliability objectives that are legally binding. So oftentimes they'll have some sort of discount or credit associated to them if they're not being met. And it's something that is usually put in a contract or even in a terms of service as a means of minimum availability a customer can expect from a product. So let's, for example, look at the Google Workspace's SLA. This one might affect you if you use Gmail for work or maybe Google Calendar for work. But you can see here that Google has stated that their web interface will have a monthly uptime of 99.9%. And that is also known as 3 nines, if you've ever heard that before. And if there's a break in that expected uptime, Google will offer you a set number of credits depending on what is actually measured as their uptime. So here you could see if it's between 99.9% and 99%, they'll give you up to 3 days extra on your bill, no charge. If it's between 99% and 95%, they'll give you 7 days free. And if it's anything lower than 95%, they're going to give you 15 days free, which is, 50% off essentially, right? So what I want to do is I want to calculate this for a given month. Let's use this month, the month of May, which has 31 days. And Google says it's going to be at least 99.9% available during this month. So I broke this down into days, hours, and minutes. So if we know there are 31 days in May, we multiply that by 24 hours to get 744 hours total in the month of May. And if we multiply that by 60 minutes, we get 44,640 minutes total in the month of May. So we're going to use this number against our percentage to calculate what the percentage actually means in terms of the month. So let's go back to our Google Workspace example. So they have a minimum of 99.9% uptime availability, right? So in order to get the potential downtime that's acceptable from that, we're going to take 100% minus 99.9%. So that's going to be 0.1%. And in order to take that into a number, we're going to divide that by 100. So we can multiply the number of minutes in the month, 44,640 minutes, by 0.001, which is equivalent to 0.1%. And that's going to tell us the amount of downtime acceptable within a 99.9% uptime percentage. And that equals 44 minutes and 38 seconds. Hopefully you're still with me. So if we know they have an upper limit of 99.9% before any free credits start kicking in and a lower limit of 99%, if we do the calculations here, which you can see in the conversions, anything between 44 minutes and 38 seconds and 445 minutes and 24 seconds will automatically give you 3 days of free service. So that's time that Google is down greater than 44 minutes and 38 seconds, but less than 445 minutes and 24 seconds that you'll get that free 3 days of credit. And you could do the same thing with all of their monthly uptime percentages. So anything between 0.1% and 0.5% is going to give you 7 free days of service. So the conversion there breaks down to 445 minutes as so the conversion there breaks down to anything greater than 445 minutes, but less than 37 hours and 12 minutes. And that's going to give you 7 free days of service. And worst case scenario, if they are down for some reason for longer than 37 hours and 12 minutes, you're going to get 15 days of free service. So you can see here how important it is to be able to translate these uptime percentages into actual time. I think it makes it a lot more tangible, and we connect this back to our SLOs to let us know how much time we actually have to solve a problem when things are going down. And that brings us to SLOs, or service level objectives. So again, these are the internal objectives. They aren't usually customer facing, but I would love to make that a thing someday. SLOs are just like SLAs, but they're the goals that we set for ourselves, like personal goals for our systems. So they don't have any legal ties to them. And often, because they're internal goals, we can use them as a buffer for our SLAs. So it helps notify us ahead of time before we actually exhaust our SLAs and start losing money as a company. So again, the beauty of SLOs is that we're trying to factor in the customers to how we manage our systems, right? So what are your customers' expectations with the features that they use most? I think this is a really good opportunity to talk to your product managers. And if you don't have one of those, just talk directly to your customers. You really want to understand how they use your product and, what frustrates them and makes them want to leave. That breaking point there is what you want to measure in an SLO. So let's take a look at another example here. So let's say, for the sake of this example, a single feature of browsing Netflix is run by a single system. And we could say the SLI for this would be average response time for loading the browsing page. Now, what I would want to know about that, and what I would need to talk to customers about, is how slow or unresponsive does my browsing experience have to be before I get annoyed and want to go somewhere else. That could be something like 99.9%, or from what we learned earlier, that might mean 44 minutes of downtime per month. And that doesn't mean 5 minutes here, 5 minutes there. It could even be 44 minutes all at once. But I think if I experience that enough times or for long enough, I'm going to start to not want to go to Netflix anymore, because it's going to feel to me like it's down all the time. So we can go back to our Google Workspace example too. And this is an example of using an SLO as a buffer to an SLA. So if we know that we have to be at least 99.9% available, we might actually set our internal SLO to something like 99.95%. And what that does is it cuts the time in half. So if normally we have 44 minutes before we have to start giving out free credits, this gives us 22 minutes. So we alert on it significantly faster and give ourselves some time to solve the problem before it becomes a problem that we have to start giving, essentially giving money away for, right? And we can do that for each type of SLA that they have set. And again, these are just examples. These aren't necessarily what Google Workspace actually uses, but at least for their SLOs. But what I would do here is I would actually set multiple targets and have them correlated to the experience that the customer would see. So, for example, the 99.95, because we're not yet breaking the SLA, I think that would be considered an acceptable experience, or maybe you would say excellent experience. 99.5% SLO gets us in time to not have to give away 7 credits for the month. And that I think would be a poor experience. So people are already breaking the SLA, but it gives us time to still get in there and fix problems before we get to the really bad experience. And that's anything under 97% uptime. And at that point, once we get to that 95% line of uptime, that's when we're going to have to start giving away essentially 50% off for 15 free days of credit for the month. So you can really see how using an SLO as a buffer can do a lot of things for us, right? It gives us time to hopefully save the company money without, killing ourselves over trying to maintain this service. I think personally that this helps a lot with work-life balance, because I can tell, if I had, just 1 or 2 errors come in that normally I would be getting emails about constantly and might feel like I'd need to jump on immediately, but maybe they recover themselves or they were anomalies. The SLO will factor that in, and I can say, oh, this only aired out a couple of times recently. It's not something urgent. I can look at this maybe not on my weekend day, but on a work day, and I can save it for Monday. And I also think that this helps us connect back with our customers, right? What are they doing with our product? What is their expectations? And how does my work affect what their expectations are? And last but not least is EB. And I've actually touched on this a little bit, but it's called error budget. And we're going to more specifically define this. So error budget is the agreed amount of acceptable downtime within a given time window determined by the SLO targets. So if we go back to our Google Workspace example, you can see what I had called actual time previously is actually our error budget. And so if we look at this in terms of an actual SLO, I'm going to take the first 2 lines here where we use acceptable and poor experiences, and you see how it affects our error budget. So in this example here, which I just pulled from like a Noble 9 dashboard, you could see I've got my 2 targets, acceptable and poor, and my chart is showing that I was almost actually exhausting my error budget. I only have 5 minutes left before I exhaust my error budget and it starts to affect customers. But what you can see here is where it says burn rate, I have it set at 0 times right now, which means I'm not currently receiving any errors that count towards my allotted error budget time. So that means I'm recovering right now. Whereas my poor SLO, I'm actually still holding on pretty strong, because you can see there was some error budget burned. It started going down, but I still have 3.5 hours left of time before I actually exhaust that budget. So because I had significantly more error budget available to me, it didn't eat through nearly as much. And in some cases, you might even only set alerts on one of these SLOs and not the other. So, I could have acceptable not alert me at all, but poor will alert me ahead of time based off of my burn rate. It all just really depends on your service and how it affects your customers. So let's recap real quick. That was a lot. Hopefully everyone stuck with me. So we went through service level indicators, which was a metric to use to measure performance of one or more services, service level agreements, which is the customer facing minimum performance agreement with legal ties, remember? And then service level objectives, which is the internal performance objective for one or more services, and our error budget, which is the acceptable amount of errors or downtime for one or more services. So thanks for joining. That was just going through the basics again. Please come back for part 2 to discuss some examples and blockers.